Welcome to EDU World Space.
Alright, so we have been given that the electric field E is equal to, let me call that K, 1 by 4 pi epsilon naught equals to K, and Qx upon x squared plus a squared power 3 by 2. Now to find the maximum value of E, we need to differentiate this E with respect to x to find out the position where E will be maximum. So this, and equate this to 0, right? So this implies kq times 1 upon x squared plus a squared 3 by 2 minus 3x by 2 2x upon x squared plus a squared 5 by 2 using the product rule for differentiation. Now kq goes to the other side and becomes 0. Similarly, we can take 1 upon x squared plus a squared power 3 by 2 common. So 1 will be on the left hand side, left term, and on the right term will be 3x squared upon x squared plus a squared. And this is now equal to 0. Now solving for x gives me x is equal to plus minus a upon root 2. And with the question that says a is equal to 10 centimeters, that is 0.1 meter, this gives me x is equal to plus minus 7.07 cm. Plus and minus denotes the two sides of the ring where the electric field will be 0. Okay, so now let's move on to part B. So in this is part A. Now for part B, we need to calculate electric field and find the graph of the electric field. Okay, now so to find the graph, I have drawn the graph in Excel. Let me take this out here. So here is the graph that I drew on Excel, Microsoft Excel. Now this shows the variation of electric field with respect to the distance. Now does the maximum that we found out, that is 7.07, does this coincide with the maximum as shown in graph? So if you see in the graph, the electric field is also seems to be maximum around this point, right? Around this point here. So this is the maximum E max, and this corresponds to like almost equal to 7.07 centimeter right here, right? So it makes sense, right? Our result coincides with the graph that I drew. Now to draw this graph, let me tell you, I have used the formula. I have used this formula here. And for the terms in that, I have used k is equal to 9 into 10 to the power 9, and that is Newton meter square per coulomb square. And q I have used is 6 microcoulomb, so 6 into 10 to the power minus 6 coulomb. X is variable, and a that I have used is 10 cm, so that is 0.1 meters. Okay, so we are done with part B. Now part C asks us to draw the electric field due to the ring, and part D asks us to draw electric field due to a point charge uh, at the center of the ring, and to make a single graph. So let me draw this in another page. So for part C, we need to find out the electric field due to ring, and that is the same expression that we wrote earlier, that is K qx divided by x squared plus a squared power 3 by 2, right? Similarly, uh, electric field E is equal to, due to the point charge, let me call that P, is equal to kq by x squared. Now the value of qx remains as they are. Now x ranges from 1 centimeter to 50 centimeters. So the graph that I have drawn here, I want to show you. I drew this graph again in MS Excel. Okay, so this is the graph that I drew, E versus X, where X ranges from 1 to 50, right? Now we have drawn that and show that the both field converge at large. Of course, the both field here, just look at this around here, they converge, right? They come to a same point and the electric field value is equal for both ER and EP, right? So yes, they converge. Yes, they converge. Yes, they converge at large x, right? Okay, now what we need to show next is at what distance does the electric field of the ring differ from that of the point charge by 10%? So if you see, electric field due to the point charge is always greater than electric field due to the ring, right? So for part, this is part D. Now for part E, so we can write electric field of ring is always less, so ER should be differ by 10%, so should be 90% of EP, so that the difference is 10%. Now for this, just equate the equation, the formulas here, the formulas equation 1 and 2. If you equate those, kx kq cancel out in both the terms. So in the ER term, we will have left x squared, x upon x squared plus a squared power 3 by 2, whereas on the RHS we will have 1 upon x squared, right? Now with a is equal to 0.1, you can easily solve this and get that x is equal to 37.07 centimeters. All right, so at this point the electric field will be 10% less, will differ by 10%. Well, we are now at the end of the solution to this problem. Thank you for watching.